1, 2, 3.
I'm glad you're here. You enjoy it? Do you already went on board?
Yes.
Yeah. Well, unlike the P3s and the C-130s of the Air Force that fly right into the hurricane, this one's just as useful for us. So, being the director of the Hurricane Center for 4 years, we don't want this in the hurricane. We want it in the surrounding area. And sometimes we want it hundreds of miles away because, what's going to steer the hurricane. So we want to look at if you have a little bit of a trough of low pressure that actually steers the hurricane to the north and actually bends it back towards the east. So we'll want to get the aircraft out there to see how strong it is. The stronger the trough, the more this thing will hit a wall. A hurricane can hit a wall basically and then turn. So we want to know the strength of those troughs. If it's not, or it's going to miss it, that can happen too. So if we have a forecast that goes to the north and that trough comes through and misses that hurricane, it may feel it and wiggle a little bit. Guess what it'll do? It'll continue its trajectory towards the west. So this thing really helps us out to determine some of the bigger type of patterns that we have in the steering mechanism. So that's absolutely just huge for us. And in some cases, it's crazy, but you can have a storm in the Atlantic headed for the coast here, but it's something up in Canada that's going to make its way down. That's actually going to eventually steer it. So we're looking way out to see what the steering mechanisms are. So it's absolutely amazing to be able to have that information. Of course, the P3s have the radar on board. They go right into the storm to be able to see the storm for us. But these aircraft here, including the P3s and the Air Force, it makes the forecast anywhere from 10 to 20% better. That sounds like a big deal. It is. That's the difference between like a situation that, I don't know, Miami and Jacksonville. Right, if you think about it, see what I mean? But that could be a big,
that would be bad.
So instead of this type of error, we squeeze that down quite a bit. So we use the information so much, and we're currently looking at I don't know if they told you, we're going to be replacing these aircraft. Yeah, so we're going to get a G550 in addition to this one, and then we're looking at the P3 aircraft, the ones that go in. We'll be replacing those with C-130s, the same ones that the Air Force have. Cool. So pretty excited about doing this, but we can't do it without the aircraft. So real heroes that go through the storms.
How can broadcasters help you with your mission to keep getting funding for this? Like, what could we do to help?
And I'll go through my spiel since you asked. Look, the Weather Service and NOAA as a whole, and I'll specifically talk about the Weather Service, we're the best bargaining government. And if you think about it, it's a penny a day per American. It's about $4 per day per American. And if you think about what the return on investment of the aircraft, return on investment of our forecast, and we do space weather as well. And if you heard some of about the GOES-U, the new compact coronagraph is on the new satellite, it's a big deal for us. So instead of waiting 8 hours for the data to see the corona of the sun, 30 minutes. So it's a game changer. And we just had that G5 event recently where people got to see the aurora. But the reason you didn't hear of a lot of damage is because we got our watches and warnings out early. So satellites have to maneuver to protect themselves from the energy. Power companies have to adjust to absorb that energy. And even in the Midwest with farming, those big tractors, they use GPS. So it impacts them. If you don't have GPS correct, you can get some big impacts even in agriculture. So as a result, the early estimates is we save trillions of dollars across the globe. Trillions, I mean, it's just amazing type of thing. So the Weather Service in particular, we influence about a third of the GMP. And for a penny a day, I think we're the best bargaining government. So any advocacy, we'll take any advocacy we can get about the mission of NOAA, the mission of the Weather Service as a whole.
Awesome.
Yeah. Any other questions? Exciting?
It's an honor. It's an honor to cover this mission.
Yeah.
It's very special.
It's amazing. This is the last in the GOES-U. This is the last in the GOES mission, starting in 1975. I mean, I was able to, even in my lifetime, see the technological advancements going from 1975 through the GOES-R in 2016. And when the GOES-R went up in 2016, all of us were like waiting for the first images. We've never seen 1 minute data, right? You've never seen the boiling of the thunderstorms and that sort of thing, and the lightning that it detects and everything. We never saw some of that stuff before. It's absolutely amazing. So fire detection, you have a lightning strike out west with no rain. You get a lightning strike, and we'll look at the satellite and actually be able to detect smoke. And the faster we can get firefighters, it'll actually detect a fire as small as a barn. Wow. It's absolutely amazing. So if we can detect that early, the earlier we can get to that fire, the quicker it will, keep it under control, that type of thing. So this plus the new coronagraph, the compact coronagraph, we're pretty excited about that for space weather. So I love it. It's exciting. And the last of the GOES. This is it.
They didn't touch upon this yesterday, but I'm assuming this will also help with like agricultural health in terms of tree health,
yes,
which would also obviously impact fire fuels and stuff like that.
You can see that, and a lot of the tree health when you get to controlled burns, and it's interesting. We have incident meteorologists that go on the front lines of all the fires across the country. We've never been so busy as we are now. Part of it's more fires, but it's prescribed burns. So when they start doing the prescribed burns, they don't do that in a vacuum. The weather has a lot to do with that. So we're actually there with them doing the weather forecast on the front lines.
To make sure the wind's as calm as possible.
Because it could get out of control.
Exactly.
People, firefighters could get
or
hurt.
if there's a thunderstorm.
Exactly.
Yeah,
because I could put it out. You think we know the wind in general, but you could have one thunderstorm here, put it on an outflow boundary, it could completely change the direction of the wind. You could go from 5 knots to 25 knots just like that, and you definitely don't want that when it comes to a fire.
Right.
Yeah. Awesome.
Thank you
good
so
seeing
much,
everybody.
sir.
Absolutely.
So the name, we get questions about the name. So it's NOAA 49, but also known affectionately as Gonzo. So if you look at the nose of the aircraft, it's a little bit different than any G4 you've seen before, right? So that's our weather radar. We actually go to the weather where most people turn around. Even though it's at 41 to 45,000 feet, we're still over, a convective tropical cyclone system. So there is going to be some turbulence. Our missions are about 8 hours long, so we'll have a crew of about 8 to 10 people inside doing those science missions for us as we're tasked. Yeah, we usually get that tasking from the National Hurricane Center, and then there's another NOAA organization, the Hurricane Research Division, that tasks us to do research. So some of the research we've done before is on how the Saharan air layer affects the formation of tropical cyclones. So right now you'll see on the news some Saharan air layers coming across. So after this event, we may get tasked to go look at some of that. Yeah, there is only one in the universe of Gonzo. This is it. So the Gulfstream 4, there is only one of those. It flies at 41 to 45,000 feet. Then we have 2 P3 Orions. So we've got Kermit and Miss Piggy. And then the Air Force Reserve has about 7 to 10 C-130Js that they fly in. Gonzo is retiring at the end of this season after 25 years of service, and we'll get a new G550. So it will be the most advanced climate research aircraft in the world. So it will have an additional, I think, 6,000 feet of altitude on it, so 51,000 feet instead of 45,000 feet. And it'll be a little faster too, right, Bot? Or a little bit faster, just a little bit? All right. These drop sons, the G4 will drop about 30 to 40 of these as it's on an 8-hour mission, flying around in front of and above the storm to characterize what's going on with the upper level winds. So when you're watching the forecasts as they come across, you'll see sort of basically a plate full of spaghetti noodles. We will orient those into one big noodle. Nowadays, the National Hurricane Center, their 3-day forecast track, we've made it accurate out to 5 days since we've been flying, and now they're doing at least a 7-day, experimental forecast track.
You actually end up having that charge effect, and so you can have like rocket lightning, and that is going to be a problem with today. I think if we get any thunderstorms, the anvils extend much farther from the center of convection, so we'd end up likely having that charged particle issue with the cirrus clouds. So
going to be on the moon and Mars, like living in 10 to 15 years. Why in God's name do these kids not understand how satellites work, what Gateway is? Oh, there's going to be another space station? Oh, do you mean other countries have space agencies like JAXA or any of the others? Like, so part of my, exactly. So my passion is educating people about modern space exploration.
see, I found my tether is being a freaking nerd, and I do a lot with Star Trek, and trying to actually be a science consultant on the show the next few, but the sci-fi community is already latched onto this, but they are in the fiction realm rather than the actual realm.
Yes.
And so I'm doing the Comic-Con circuit this summer, and I'm giving 2 presentations on weather and Star Trek. If you show people in a very peripheral way how we're really doing things, then they kind of get sucked into orbit and they decide to search it on their own.
What a good analogy.
Yeah.
Good job.
My whole job is translating science to reasonable explanations. So I found explainers like that.
And you can even add the extra level with respect to lightning with how it's related. If you ignore the size differences, the way lightning fires is very similar to the way a neuron fires.
Yes.
I did that was my undergrad thesis.
It's so cool because my
Bachelor's in
friend,
neuroscience, bachelor's in geography.
yes.
I just wanted to know how you went about testing the satellites on Earth. You know, given the conditions are completely different. Obviously, the satellite's like something like 23,000 miles up, so you can't get that sort of range on Earth. So I was wondering how you went about stress testing that sort of thing.
The instruments and the satellite both go through a very rigorous testing regime that very closely resemble the environment of space. So first off, we're going to send it through a vibration testing that's going to shake the instrument and simulate the vibrations that it'll feel when it's launched and put into orbit. And then we'll take the instrument and we'll put it through a thermal vacuum chamber testing, where we will suck all the air out of the chamber as it is in the vacuum of space, and then we'll send the instrument, the satellite, through a series of hot and cold cycles that those instruments on the satellite they'll see in a daily cycle in the geostationary orbit. And then finally, we'll send it through some electrical testing and some electromagnetic interference testing to make sure that the instruments aren't interfering with the other instruments on the spacecraft. So all the instruments and the spacecraft go through a very rigorous environmental test campaign, which takes several months and is very rigorous and is witnessed by NASA and NOAA along the way.
What makes the GOES-R series, and particularly the GOES-U satellite, unique compared to other weather satellites? Is there anything comparable, or why is this different?
There is something unique on the GOES-U spacecraft that's different from the GOES-R, S, and T satellites that are the other three in the series, and they're currently on orbit. And that is that GOES-U has a new instrument called CCOR. It's an acronym CCOR. It's a compact coronagraph, and it's the first of its kind, and its mission is to measure the outer atmosphere of the sun to monitor for coronal mass ejections. So when we can detect these being directed towards the Earth, that is when our Space Weather Prediction Center at NOAA will start to send out warnings to the general public about potential disruptions in comms, power systems, navigation, things of that nature. So that's our first early warning detection and a new instrument on GOES-U.
Curious about the propulsion system that takes it and sort of like locks it in place out there. And then does the satellite have to unfold and, you know, it's like it's packaged in this capsule? How does that process work?
On the bottom, you can kind of see the black portion that sticks down there. That's called the liquid apogee engine. So after the rocket drops us off, the liquid apogee engine is what takes us the rest of the way out to our final orbit, so through a series of burns once we're out in space. Then there's some smaller thrusters. Some are kind of hard to see, but they're the small silver items that are sort of hanging down from the bottom and off around the side. Those are minor thrusters that we use once we're out on orbit, just for repositioning and kind of station keeping when we're there. And then, yeah, as you mentioned, it does not launch on the top of the rocket looking like this, right? We've got to fold it up. It's got to be nice and compact to fit up there in the fairing on the top of the rocket. And so these items deploy when we're out in space. The solar array deploys fairly early, at least the first 4 panels, so that we can get power to the satellite, and then other items deploy later on in the flow.
Mike Ashby on X asks, will GOES-U be used for wildfire detection globally?
The GOES-U satellite, once it reaches orbit and it goes through that very rigorous test checkout process, first that occurs on land, and then when it's on orbit, it takes about 6 months until it's handed over to NOAA. It will be monitoring the GOES East footprint. So that roughly extends from the west coast of Africa over towards the western continental United States. There is geostationary imagery that's pictured together that captures all around the globe. But for NOAA, we have an operational GOES East, which will be what GOES-U eventually becomes. Then there's an operational GOES West. We have partners over in Europe at the European Meteorological Space Agency called EUMETSAT. They operate 2. And then there is another geostationary sensor operated by JAXA in Japan. So that creates the complete picture of the globe. But for GOES-U, it will monitor and pick up on fire hotspots, and it'll be used for fire detection as well as smoke monitoring, but for the GOES-U footprint.
My invisible microphone. What is the expected lifespan of the GOES-19? What's in geostationary orbits?
For our GOES-R series spacecraft, the 4 of these will carry us into the early 2030s and beyond. There is a follow-on mission that is already being planned called GEO Extended Operations, GeoXO for short. That first satellite is planned to launch in the 2032 timeframe, but GOES-U lifetime will last several years after that point, so mid to late 2030s.
So we've time traveled to 2044. What does the ideal satellite look like for weather monitoring?
So if we fast forward to 2044, we will be in the era of the GEO Extended Operations. So we'll still have instruments that are in the current payload, like the Advanced Baseline Imager and the Lightning Mapper, and several others. But in addition to that, there's going to be additional instruments that monitor atmospheric composition. So for aerosols, we'll have a new instrument called ACX, and then there will also be a new instrument to monitor ocean color for the health of the ocean. So that's what it looks like. It also means more data, more information to archive, could make it harder to process as we keep increasing in temporal resolution and spatial resolution. But that's what the geo landscape looks like. So there will be a continuity of operations. We just keep adding new features and making the imagery better and better in more high definition.
So those images that we're seeing, we'll see at 4 times the resolution. That's going to be the real game changer for GeoXO.
With all of the data that you're collecting, I imagine it's a massive amount of information to sort through. So are you using any kind of like AI or machine learning in order to filter through a lot of that data? And then what matters to just the common person that's worried about weather and how it impacts their life?
At this point, we are still investigating what can be used most safely. Obviously, AI is extremely powerful, but it is of the utmost importance that no important data is missed. We always want to be innovating, but the safety of the rocket and the payload comes first and foremost. We are currently exploring AI tools which will be used in partnership with the human engineers, but we will certainly not be replacing human engineers in the foreseeable future.
How do you communicate with the satellite once it's at its new home?
NOAA has the 24/7 command and control of the satellites. So it's signals going up and then coming down in the X-band. That's how we retrieve the data. We've got 2 ground stations at NOAA. We've got one at Wallops Island, Virginia, that we use for our GOES and our geostationary satellites primarily. And then another ground station up at Fairbanks, which we use primarily for our low Earth orbiting missions. But we have 2 mission management controllers that are on site 24/7, 365, the nights, weekends, holidays, and snowstorms, making sure that those communication signals are intact. We also have 2 product operators that sit on console to make sure that data products are coming down and being produced.
Artemis 3 is also in production, so that's going to carry 4 astronauts on a trip to the moon. And then Artemis 4, also in production here, will be the first one to dock to kind of our new lunar space station called Gateway, which you're going to learn about a little later. The building's a little multi-purpose. You see the astronauts walk out to get in their car before they go to the launch pad. This is the building that they stay in. Down a very long hallway that way, and up a couple floors is where the astronaut crew quarters is as well.
Artemis 2's goal is to go around the moon, just like Artemis 1 did. What's the difference between the 2 missions? People, astronauts. You all probably already know the names of the astronauts. We'll have Christina Koch, who will be the first woman to go around the moon, Victor Glover, who will be the first person of color to go around the moon. You have Jeremy Hansen, who will be the first non-American to go around the moon. He's a Canadian Space Agency astronaut. And then you have Reid Wiseman, who is the commander. And Reid Wiseman is not just an astronaut, he was the former head of the NASA astronaut office. So we don't just have like an astronaut, we have like the astronaut as our commander. So we're all very excited. This is a really great crew. They're going to go around the moon in the same orbit where we'll eventually put the Gateway space station in orbit around the moon. It's a much larger orbit around the moon than any of the Apollo missions have done previously. So that means all 4 astronauts will go further from Earth than any human has ever gone before.
Wow.
So you'll have all those milestones of all the people from different places that have ever been there before, and also all of them will go further than anyone has ever gone before. So exciting history is being made right here inside this building. It's fun to be a part of it. George W. Bush became the president, and the idea was that you wanted to have a spacecraft that could go to the moon and to Mars. So that means we need to create a spacecraft that could withstand that type of duration, be able to go to the moon as well as then be able to go to Mars. But the Lockheed Martin was smart at the time, knowing that you would have multiple presidential changes. So Obama came in, canceled the idea of going back to the moon, decided he wanted to go to an asteroid. Trump came in, decided not to go to an asteroid, decided we're going back to the moon. Biden came in, Biden decided, yep, moon, keep on going. That's good, Artemis good. So the requirements of the spacecraft changed. Guess how much the design of the spacecraft changed between those 4 administrations? None. George W. Bush became the president, and the idea was that you wanted to have a spacecraft that could go to the moon and to Mars. So that means we need to create a spacecraft that could withstand that type of duration, be able to go to the moon as well as then be able to go to Mars. But the Lockheed Martin was smart at the time, knowing that you would have multiple presidential changes. So Obama came in, canceled the idea of going back to the moon, decided he wanted to go to an asteroid. Trump came in, decided not to go to an asteroid, decided we're going back to the moon. Biden came in, Biden decided, yep, moon, keep on going. That's good, Artemis good. So the requirements of the spacecraft changed. Guess how much the design of the spacecraft changed between those 4 administrations? None. You had to design it to be able to go further duration. Lockheed Martin's building a spacecraft. Our customer, NASA, can decide where they want to send it. Will enable us to start building a space station around the moon. And that space station called the Gateway has its own propulsion and power element, which means it can change its own orbit. The goal of the Artemis program is we want to go to the poles of the moon, because Jefferson Crater is so deep the sun doesn't touch the bottom of it, which means we believe that there could be solid ice resting on the surface of the moon. If you have solid ice, that means you can go get it, you can melt it, you can drink it, you can split it into hydrogen and oxygen. Oxygen obviously is something that the astronauts can breathe. Hydrogen is what the future human landing systems are supposed to be using for their descent, which means you can now make a gas station on the moon. So the ability to find water on the moon is a major goal of the Artemis program.
What are some other items that you're regularly shipping up to space?
So there are 2 types of deliveries that we have for the Gateway. One is what we call a fast transit, which goes from the surface of the Earth to the Gateway in about 3.5 minimum days, usually about a week, to do all the flybys and burns. And then we have a slow transit, which means we can deliver more cargo over a long period of time. And what we do is we come from Earth, we have this big slingshot of the moon because the Earth is orbiting the moon. So we use that momentum and fly into space, and then we slow down out by the sun, and when the moon has come back around again, we can use its energy to slow us down and put us into the orbit that we need to go into. By doing that, we can handle more cargo, but you're also in space for 180 days in a pressurized tube being blasted by radiation. So you have to consider what you're transporting. Is the food in a radiation-safe container, and how long can it last in orbit? Because if you're delivering food, it might be a problem. If you're not delivering food, you're delivering outfitting equipment for Gateway, power payloads for the power payload racks, astronauts' diapers, or uniforms, or toothbrushes, then you might be all right floating around for 180 days.
And how do you test a lunar landing?
High-fidelity computer simulations that test lunar landings. Thanks to the Low Lunar Reconnaissance Orbit, LRO, we have a very high-fidelity map of the South Pole lunar surface. So we know what that environment looks like, and we have some test sites picked out. Now, no matter how high fidelity it is, there's still uncertainty, there's boulders we didn't see, there's places in shadow. And there might be maybe some noise in the thruster that it doesn't thrust exactly where it should, and it ends up a little bit off course. So we have to plan for those contingencies. And so it's a lot of simulation based. Now, once we get the simulations working, we have a big lunar dust bin and a gravity offloader that simulates lunar environments. It doesn't have thrusters in it, right? It's just a big dust bin. So we don't want to fire rockets inside of a closed room like that. But we can simulate the dynamics and the resistance that would be generated by a thruster. So there's a lot of different ways we can test these things, and we do all of them.
Thank you.
I heard like the first woman that went into space, she was sent with like
100 tampons.
Yeah.
So there's actually, I mean, it sounds like it was complete ignorance, right? And in a way it was, but I think it's painted quite the right way.
I heard like 1,000, so 100 is probably better.
I don't know what the number was, but we certainly did not know what the female body would do in space. And so it's better to have an extra amount than not have enough. When the Apollo astronauts came back from the moon, they were quarantined for 2 weeks because we were worried there would be space germs and that they would contaminate all of Earth. So there's always this extra step of risk averseness that we take. Provide too much. They'd rather have too much or be too safe rather than not enough. How many of you have seen The Expanse? So you can see that the big change in The Advance was when they all of a sudden discovered this new drive that is so powerful, it could accelerate so quickly on so little fuel, completely game-changing. We need something like that to have these supply chains, to have these regular service to and from Mars.
Based on your experience and expertise, what are your predictions?
It's nothing quite that exotic. Our next step is nuclear thermal propulsion. And it's not actually a new technology. We've had some form or another in the past 30, 40 years. It's pretty much the next step we need in space. So that can cut down our Mars transit time in half. We're working on that now. Our Mars transit vehicle should have a nuclear thermal propulsion device.
By when?
Ask Congress. If we have a continuing budget, then we can get it done pretty quick. The biggest challenge to NASA is every 4 years, our priorities change.
And assuming the government approved NASA's budget, how long till?
If we were back up to 4%, we would already be on the moon. We'd have a base, and I think we'd be thinking about Mars.
Is only NASA operating Gateway, or are other space agencies taking part?
Good question. So Gateway is an international effort. So Maxar, which is this one here, this is the power and propulsion element, and that's made by Maxar, which is an American company. And then Northrop Grumman is manufacturing the Habitation and Logistics Outpost, which is their first habitat. After that, it gets more international. We have the Esprit refueling module manufactured by the ESA, and then the International Habitat manufactured by the ESA and JAXA. And then we have the recent new addition to our international partnership, which is the Mohammed bin Salman Spaceport, which is the UAE participating in building the airlock module. So it is currently international. We're always looking for more international partners to participate, especially with science payloads and other research opportunities. Of course, the lunar base on the surface is still wide open for participants to collaborate with us and make that work.
Welcome, my name is Matthew Vickens. My expertise was in lighting. We formulated light recipes where you can change the color to grow crops a certain way. I'm going to take you into the plant processing area. This is where we do a lot of our ground research.
Accurate was Matt Damon and on Mars growing potatoes.
Oh man, I love that movie. I don't know how safe it would be to use species as fertilizer. You know, that's in my mind. I'm the point of contact for food safety here, and trying to figure out what are the hazards of E. coli. Also, growing potatoes. That is something that is actually not new. Let me bring you over here. This is called the biomass production chamber. It was active here at Kennedy Space Center at Hangar L from 1987 to the year 2000. Completely closed chamber, but it actually had different layers like vertical farming. NASA was actually vertical farming before vertical farming existed. And one of the crops they grew in there were hydroponic potatoes. So actually the movie kind of got some of its intel from research that we had already been doing here for 20 years. So in terms of being a pioneer for what we call controlled environment agriculture, all of that actually started here in the efforts for space exploration. In the microgravity environment, astronauts sometimes have reported losing or diminishing their sense of taste. And so a lot of them are asking for spicier foods. Can we modify the taste in space using the lighting that's already available? You can change the taste by changing, for instance, a ratio of certain colors. How does the color of the light change the flavor of the plant? There are recipes, for instance, that have very high energy. So for instance, we're looking at the spectrum. Higher energy is more towards blue. When the plants see a lot of blue light, they stay short because it's a lot of energy. And there's only so much that they can take. So when they're exposed to that much energy, they start protecting themselves. Almost kind of like when we go out to the sun, our skin starts to tan. Some tan more than others, but plants also produce these pigments that absorb the excess energy. And so those pigments actually can change the flavor profile of the crop. And that's one way to do it. And we actually want to migrate beyond lettuce. We've flown a lot of what we call leafy green crops because they grow quick. Normally, field-grown lettuce takes 70, 75 days before you can produce a head of lettuce. We can do that in 28 days in a controlled environment. So not only does it grow quick, but lettuce, you get to eat the whole thing. So that's another thing to consider is that, you know, in space, there's not a lot of space, right? So we're limited by volume, by mass, by power. But lettuce is one of the more efficient crops because we can not only grow it fast, but we can eat the whole thing without having much waste. Yeah. Say, for instance, if you're growing a flowering crop like tomatoes or peppers, you got to grow a lot of inedible biomass before you can actually get your flower and then your fruit. Mm-hmm. So you actually got to figure out what you're going to do with that excess waste. So leafy greens gives us an advantage where we don't have a lot of waste. We have these in the classrooms where the students can actually grow plants and make recommendations for us here at NASA on what's the next crop for us to fly in space. And so far, we've actually gotten at least 2 crops as recommendations for us, and we've flown them as a result of the citizen science research that happens in the Growing Beyond Earth program.
Which were they?
I think one of them was dragoon lettuce and pop-toy. Those were the 2 crops that ended up recommending to us, and we flew them, and they grew great. You may know ISS will be retiring by the year 2030, and so the next platform is Gateway. Gateway will be in a further out orbit, what we call cislunar space. It will allow us to have access to a higher radiation environment. It will be quite small, smaller than the ISS, but still valuable. We are going back to the moon. We are working actually with the Canadian Space Agency on how we can have different demonstrators for growing crops on the surface of the moon. The lunar surface is going to be a huge opportunity to get practice for when we go to Mars, which is next. We've got the Mars Transit Vehicle area where plant growth will be required. That's a 9-month trip at least. Then we're talking about moving away from research and actually utilizing plants as a supplemental food option for the fruit. And then surface habitats, of course, that'll allow us to grow, you know, in larger footprints, corn or soybeans, or even utilizing techniques such as hydroponics. Plant growth research or plant growth as a supplement to the diet is going to be necessary. You may see a lot of tall flowering plants in the corner there. Yeah. So we've got some projects where we're actually growing plants for teas. Like we've got chamomile growing, and so that we're trying to actually purposely grow it to flower, have potential plants that can be made into teas. There's a concept called the K-cup, or you know, the coffee cup in space, where if you shape it a certain type of way, you use the surface tension of water to move it in a certain direction, because water in space moves drastically different than here on Earth. And so we're trying to figure out if we can use that design as a way to grow plants hydroponically.
It's 59 years old, weighs 6.65 million pounds. It's the Guinness Book of Records is the heaviest self-powered vehicle in the world. Okay, so I imagine later on you'll go out to the pad, you'll see the mobile launcher. That's what we stacked the rocket on. I'm sure Madison probably told you the mobile launcher will bring it over into the next bay here in a couple of months. They'll start stacking the rocket on top of that, and then we take it back and forth to the pad. So everything that's ever gone to the pad since the very first Saturn V mission rode on either this crawler or the other one that you'll see in a little bit.
That is our sound suppression system.
With it being in and out of weather violations, saying no-go, is that for the expected zero time, or is it through the entire window?
It's for the current time, and then the launch weather officer will also try to time out an estimated clear time. So we might say, well, no-go.
How much spatial would we need?
It depends. For this particular launch, we gave them a 50% chance of violation at the beginning of the window, 70% at the end. So weather overall should get a little worse, because we're getting the tops of those thunderstorms to the west blowing off over us. Today is not exactly working out as we had expected. Like, we thought the development of the initial storms would be a little farther to the west, so the front end of the window is a little worse. We're saying a 1 in 2 chance of actually having a weather violation, which actually is happening right now. But again, we're forecasting for the window, not just the count, which extends 2 hours in advance of that.
Thank you.
On launch day, it's not my fault.
All right, world. We are on our way to NASA Kennedy Space Center. And it is early. All right.
It's 59 years old, weighs 6.65 million pounds. It's the Guinness Book of Records is the heaviest self-powered vehicle in the world. Okay, so I imagine later on you'll go out to the pad, you'll see the mobile launcher. That's what we stacked the rocket on. I'm sure Madison probably told you the mobile launcher will bring it over into the next bay here in a couple of months. They'll start stacking the rocket on top of that, and then we take it back and forth to the pad. So everything that's ever gone to the pad since the very first Saturn V mission rode on either this crawler or the other one that you'll see in a little bit.
That is our sound suppression system. So just within milliseconds of a liftoff, they empty that tower. It's about 400,000 gallons of water that they take and they flood the launch pad. It's not for the fire and flames, it's for the sound. So the sound waves are very damaging coming off a rocket that large. And so that system suppresses those vibrations to make sure that the pad infrastructure stays safe.
Four, 3, 2, 1.
Go you.
Liftoff of GOES-U, NOAA's newest weather satellite, to monitor the Earth and Sun in high definition. The rocket is now powering down for max Q. Max Q is the moment of maximum dynamic pressure on the rocket. The vehicle is now supersonic,
Falcon Heavy is supersonic.
Traveling faster than the speed of sound. A great shot from on board the rocket, looking down on the Earth that it is leaving. And all 27 Merlin engines providing 5.1 million pounds of thrust. A lot of things happening here. So again, we have the 2 boosters that are going to be returning to the Cape here. Wow, look at that as it guides its way back down. Woo! Just heard the 2 sonic booms here in the room.
EY/NY landing light display.
Our monitors shaking as we watch these 2 boosters land.
We have successful landing of the 2 side boosters. Everybody looks great.
So far, so good. Really exciting launch.
Very exciting launch, and we got through that weather, and GOES-U's on its way.